Okay, what I want to do now is I want to answer the following question. So here's our first normal distribution question. And just suppose that we have some quantity that's normally distributed with mean 2 and with standard deviation equal to 1.3. What I want to do is I want to compute the probability that a randomly selected value is less than or equal to 1. So just to get an intuition, and I'm not going to do this, I think, beyond this example, but we have a mean of 2 and a standard deviation of 1.3. That means it's going to be a little bit more spread out. Again, my drawings can't be that accurate, but here we have a mean of 2 and a standard deviation of a little more than 1. And I want to compute the probability that a randomly selected value is less than or equal to 1. So here's our cutoff 1. And what we want to do is we want to compute the area from negative infinity to 1. So in other words, the area under the curve here, and this is going to go all the way to negative infinity. Okay, so we want to compute that red area there. Okay, now a few things that I want to mention. The area under the total curve is 1. The curve is symmetric about the line x equals 2. What that means is that this area should be less than 1/2 because the area from negative infinity all the way up to 2 should be exactly 1/2. So if we only go up to 1, that should be less than 1/2. So it doesn't exactly tell us what the value is, but we know that our answer should be positive, but less than 1/2. And that at least gives us an idea of what probability we're getting. So that, it's not, again, not going to give the answer to you, uh, but if your answer is like 0.8 or something, we know something's gone wrong. So what we're going to do, and there's two ways to do this, but first I want to explain how to use this probability table. And this is historically how this was done before a lot of technology was widely available. But what we're going to do is we're going to compute the standardized value for this. So we need to figure out what's the corresponding z value. And so z is going to be our x value, which in our case is 1, minus mu, minus the mean, which is 2, divided by the standard deviation, which is 1.3. And so that's going to be negative 1 over 1.3. And so let's think about what that is. There's numerous ways that we could calculate what that is. Let me just get out my calculator from high school. It's really my calculator from high school, by the way. And 1 divided by 1.3 is 0. So this is negative 0.77. I just want this to 2 decimal places, and I'll explain why. But this is negative 0.77. And then what we're going to do is we need to figure out if we convert this to, so this is the normal distribution with mean 2 and with standard deviation equal to 1.3 squared. So that's 1.3 squared is 1. Whatever it is, 1.69. So that's the normal distribution. We're going to convert this to a problem about the standard normal distribution, which is where we have n of 0, 1. And it turns out that the area under the standard normal that's going to be the same will be the area from negative infinity up to this value, negative 0.77. And that'll turn out to have the same area. And so the table that we're going to use is going to be a table that's in the handouts. So on Canvas, under modules, there's a handout module, and I think the first or second item there is a list of formulas and tables. So let's jump over to that now. Okay, so I'm going to jump over and let's look at that. Okay, so this is the sheet that has all of the formulas on it for the semester. So remember, this is totally fair game to use on any exam that you'd like. And this has all the formulas that you ever need on it. Chapter 3 actually has this formula for the standardized variable. Just notice that that formula is actually something that was initially introduced in chapter 3 or yeah, I don't know why, but anyway, so it's also here in chapter 6. So the normal distribution has that z-score. This is again called the standardized value, okay? And that's what they call it there, standardized value. So This is the sheet of all the formulas that you're ever going to need to know for the course. And this is not the point of what I wanted to show you on the sheet. What I wanted to show you is that on page 5, on page 5, there's the formula, there's the table for the standard normal curve. And what this table is going to do is this has on it all of the values on the curve from -4 to 4 up to the hundredths place. So this goes from -4, -3.99, -3.98. And what they're going to do on the sheet is they're going to tell you what is the area, what's the integral, in other words, what's the area from -infinity all the way up to the z value. Okay, and so if we want to know what's the area under the curve from -infinity to -0.77, this is exactly the type of question that we can use with the table. And so what we're going to do is I'm going to zoom in just a little bit here. Okay, and so the vertical column, z, is going to be the first, it's going to be the units digit and then the first decimal, the tenths digit. And we had -0.77. So we're going to look at the row that has -0.7, and that's going to be here. So that's going to be this row, so -0.7. And then with that, let's see if I can get this all in the same shot here. With that, we're going to look at the column. So we're going to look at the column that has, again, it's -0.77. So we're going to look at this column that has 7 in the hundredths place. And when we do that, we're going to end up with -0.7. So that's going to give us this row. And then we're going to stop when we get to 0.07. And we end up with this number 0.2206. Okay, so that's how we're going to use this table. So again, the vertical column gives you the units digit in the tenths, the first decimal. And then the horizontal, the different columns, give you the hundredths digit of the decimal. So we found that it was -0.77, and this is 0.2206. One other thing I want to mention, and I love this part of the table, is that notice that we're looking at this picture here. This reminds us that these numbers that they give you are the cumulative probabilities, the probability from -infinity all the way up to z. If we wanted to find the area to the right, we would have to just manipulate this somehow, and we'll talk about problems like that soon. Okay, but let's go ahead then and let's look at, so let's go back, and where we can now answer this question just using the table. We found that the probability, there we go. So we found that the probability that a randomly selected value in our normal distribution with mean 2 and standard deviation 1.3, the probability that a randomly selected value will be less than or equal to 1 was 0.2206. And again, we use this -0.077 to figure out how do we use the table, because the table has to do with the standard normal, and then that is going to be the same area as the one that we're looking for. So that'll be our answer there. So our answer is about 0.2206. So if you have a quantity that has a mean of 2 and a standard deviation of 1.3, the probability that a randomly selected value will be less than or equal to 1 is 0.2206. Notice that this agrees with what we said before. Our answer should be somewhere between 0 and 1/2, and in fact it is. Okay, so that's how we use the table, and we'll use the table a few more times in a few more examples. But I also want to share with you how we use this. So I also want to show you how we use this using R. So let's jump over to R. And in chapter 6, there's going to be 4 functions that'll be relevant for us. But really, there's going to be 2 main functions, and that's going to be p norm and q norm. And don't worry about q norm for now. We'll worry about that later. For now, I want to show you the p norm function. And the p norm function is exactly the cumulative probability like we had in the sheet, like we had on the table. And so we wanted to find p norm of -0.77. And if we type that in, what it'll do is it'll give us the value on the table that was about 0.2206. So there we go. So this is 0.2206 499. If you just type p-norm of whatever your value is, that'll give you the value under the standard normal distribution. But you could also actually just use this directly, and we wanted to know what's the probability that a randomly selected value was less than or equal to 1, given that we had a mean of 2 in a standard deviation of 1.3. Now this will not be exactly 0.2206, it'll be close, but notice that it can't be exactly that because the negative 0.77 we got by rounding. So it'll be close, but not exactly. And there we go, so it's 0.2208 or 0.2209 if we round to 4 decimal places. Okay, so that's how we can use R and how we can use the table to get these probabilities. So again, the relevant values. So if we think about the table of, if we think about this normal distribution table, those values we get by using the p-norm function. So p-norm and the values on the table are cumulative probabilities. In other words, area from negative infinity all the way up to whatever value we're looking at. Okay.